In this lesson, we're going to look at some properties of numbers. Some of these properties, so for example, we're going to look at factors, multiples, also things called highest common factors, lowest common multiples, which you might have heard of before. And all of these things, they're really useful when playing around with numbers, when doing different things with them. So one thing in particular that we're going to do pretty soon is we're going to start looking at fractions. And both of the kind of more complicated of these number properties we're looking at, they're really helpful when you're working with fractions. So let's have a look. So the first one is called a multiple. And as the name might suggest, a multiple involves just multiplying that number by our counting numbers. So 1, 2, 3, 4, 5. So going on forever. So you can have as many multiples as you like. You can keep finding multiples forever. So multiple involves multiplying, right? Hopefully that's fairly straightforward. So for example, here we've got the multiples of 5 written out. The first, we got 6 of them. I'm going to do the first 6 multiples of these two numbers. Let's have a look. So, for 2, the first multiple of any number is just itself. 2 times 1 is 2. And then we go, the next multiple will be 4, 6, 8, 10, 12. And now we've got 6 multiples. So each time I'm just multiplying by the next number, yeah? Next whole number. For 7, so first multiple is, of course, itself, and then the next one is 14, and then 21. 3 times 7 is 21. What's 4 times 7? 28. And we got, 35 and 42, and we can stop there. That's 6. But, I mean, these, of course, go on forever, yeah? There are more of them. And, if you know your times tables, you're just listing out the times tables, aren't you? And that's how you find multiples. A factor, on the other hand, is a number that divides into whatever your number you're talking about, divides into it cleanly or nicely, so without leaving a remainder. And I'll show you a way to find factors. I find the best way to do it is give yourself plenty of space on the page. And let's get into it by doing 10 and 18. So give yourself plenty of space. And what I do is, with factors of a number, right? If you divide the number by itself, so say we got 10 and we divide by 10, we're always going to get 1, right? So we know 1 and the number itself, in this case 10, they're always going to be factors, right? So I write them really far apart on the page, and then I just try numbers going up. So the next one, 2, does 2 go into 10? Well, 10 on 2 is 5, right? So 2 is a factor, so is 5. So I'm just writing them kind of far apart, leaving space in the middle. 3, does 3 go into 10? No, it doesn't, so I won't write it down. 4, that doesn't go in nicely either. 5, well, actually, I've already written down 5, so I can stop. So the way this way of working out factors works is write the numbers really far apart, 1 in itself, and then just fill in the gaps. Once you reach a number you've already written down as a factor, you've definitely found them all. So it's kind of a foolproof way of making sure you find them all, rather than just kind of vaguely trying to remember your times tables and which numbers fit. Let's do it again for 18. So we got 1 and 18. And then 2, if you divide 18 by 2, you get 9. So there's no remainder there. That's nice. So it fits in. 3 goes in. You divide it and you get 6 is the answer with no remainder. So that's fine. 4, does 4 go into 18? So we could check by just doing a little bit of short division. So 4 doesn't go into 1, into 18. What goes 4 times, and there's a remainder of 2. So that doesn't work. It doesn't get to be added to the list. 5 also doesn't go into 18. So we're done. We found all the factors of 18. There we go. One thing that when we're talking about factors that kind of comes up a bit is the idea of prime numbers. So a prime number is defined these days as only having 2 factors, 1 and itself. Now you might think, the number 1, that seems like it should be a prime number. It's like, it seems pretty special kind of thing. But if you think about this definition carefully, 1 only has 1 factor, 1. Right? So it doesn't fit into our definition. Now, in the past, actually, it was considered a prime number. And so maybe you think, I reckon it should be a prime number. In that case, I'd recommend you to write to your local university and tell the maths department, you guys should start thinking 1's a prime number. Unfortunately, that might take a while. So probably just stick with the definition we've got. But so prime numbers, 2 is a prime number, right? 1 and 2 are its only factors. 3, also a prime number. 3 and 1 are its only factors. But if we look at the ones we were just working with, they've got way too many factors, right? This one's got 4, this one's got 6. Too many factors, they're not prime. All right. Lowest common multiple. So the lowest common multiple is the smallest multiple of two numbers that is shared or common, right? So one way to find the lowest common multiple that you won't make a mistake is if you just list the multiples of numbers until you find a match, you'll definitely get there, right? Once you get a bit more confident with this, maybe you could just kind of think off the top of your head, oh, I reckon it's this, and you might be right. But we'll just do it the kind of slower but more careful way. So we want the lowest common multiple of 6 and 4. So sometimes it's just written LCM. Now, so it's multiples, right? So here's 6, here's 4. So what we'll do is we'll just write out their multiples, kind of like we did above, until we find a shared one. So multiples of 6, 6, 12, 18, 24, 30, 36. When we stop there, find someone for 4 and see if there's any matching ones. So 4, 8, 12, and we've actually already found a shared one, right? So 12 is shared by both of them. So the LCM of these two is 12. Okay. Highest common factor is the largest factor of two or more numbers that is common or shared. Yeah. So let's have a look at 40 and 12. So again, the kind of way to do this without making any mistakes is if you list all the factors of both numbers, just look at which one's the biggest that is shared between them. So let's have a look with 40 and 12. So 40, the factors of 40, so we got 1 and 40, 2 and 20. 3, does 3 go in? No, I don't reckon it does. It's going to leave a remainder. 4 does though, 4 and 10. 5, I reckon that's going to go in. 5 times what is 40? 8 is good. 6, does 6 go in? No, it doesn't. 7, that doesn't go in either. So we found all our factors because we've breached back at 8 and we already wrote that one down. All right, 12. So we got 1, 12, 2 and 6. 3 and 4, and now we're back at 4, right? So we can stop there. All right, so highest common factor. So we got some common ones. 4 is shared. Anything else shared? 5, no. 6, 8, no. All right, so 4 is our HCF, highest common factor. So sometimes they're not that big. In this case, it was only 4, but there you go. Now, why do we learn about lowest common multiples and highest common factors? So both of these are really helpful when we're dealing with either adding and subtracting or timesing and dividing fractions. All right, final example. We've got ourselves a list of numbers here, and from this list, we want to find a factor of 25. So if we look at these, the kind of ones that are tempting are probably 10 and 5, but actually 10 doesn't go into 25 nicely. Whereas if I divide 25 by 5, I get 5 with no remainder. So a factor of 25 of these numbers listed here is 5. A multiple of 4, so the only one there, I did recently write this out, is 8, right? 4 times 2 is 8, so that counts as a multiple. And then the prime numbers, so if you think about it, the only factors of 5 are 1 and 5, so it's a prime. For 6, it has 1, 2, 3, and 6, so that's too many. But 7 is just 1 and 7. 8 has too many factors, 2 and 4. 9 has more factors, right? Because it's also 3 times 3, and 10 has too many factors. 2 times 5 also is in there. So our only ones are 5 and 7. And that is it for our prime numbers. And that's it for this lesson. Thanks for watching.